Okay, let's start the class today. So I hope I'm audible to all of you clearly.
Yes, sir.
Okay,
Yes,
fine.
Yes,
sir.
sir.
Okay, great. Okay, so let's start with functions. We have already, had an introduction to functions in yesterday's class. Let's get to the yesterday's page. Okay, there it is. So we discussed this small program about functions yesterday. Today we're going to take it further. But I'm sure all of you have understood what I have written it down in this, page. Okay. So today we're going to understand what exactly is happening behind the scene. Okay. When I write this program and when I run this program, what exactly happens behind the scene? So let's go ahead. So all of you know that in the first line, we declare three variables. Okay. So in the memory, right? Which part of the memory these three variables are going to go? These are going to go into your stack segment because these are all temporary variables. So in the memory, you have memory allocation done for A, B, and C. Okay, no values have been assigned, so no values are there. In the second line of the code, we are taking the values of A and B from the user, right? So we are asking the user to enter two values, and that's done by using the scanf function. Okay, so the user enters two values. Now let's say he enters 3 and 4. So the value of A is initialized with 3, and the value of B is initialized with 4. All right, let's go to the third line. Now this line, what's happening is there is another variable C, but this C is basically waiting for some value which is going to come from this function. Now, what is this function? Add A comma B. Now, let's try and understand what exactly happens here. Now, this is a user-defined function. Where is the body of this function written? Here. Here is the body of my function. Now, what exactly happens here is I am passing A and B. Okay. What this does is a copy of these two values is made. That means a copy of 3 is made and a copy of 4. That means in memory location 3 and 4 exists in this location which is pointed by A and B. But what we do now is we take a copy of these. That means a copy of 3 is made and a copy of 4 is made, and a copy of 3 comma 4 is actually sent through this function. So now when this function call takes these two arguments, that is 3 comma 4, it is not taking the actual argument here, but what it is carrying is a copy of that. Okay, so it carries the copy of these two values. So 3 and 4 are the copies of these values. They are not the actual values. It's just a copy is made. A Xerox copy of those values are made, and that copy, this add function is carrying all the way to the body. So the add function brings the program control to this line of the code, and it carries 3 and 4. So when it brings the value, right, when it brings the value to this part of the code, obviously that value needs to be stored in some container because it's like a copy is coming. So when the function call gives the value to the function body, these values are stored in this and this. Now what I have written here is int A and B, but what actually happens is two separate memory allocations are done here again. So in memory already I have 3 and 4 somewhere else. Okay, now once the function brings these arguments into the function body, int A and int B, two separate memory allocations are done once again. And what happens here? The copy which the function was carrying is deposited into this A and B. All right. Now what happens is A and B is not this A and B, but it is this A and B here. The A and B which is inside this function, right, is this A and B is not the A and B from here, but it is the A and B from here. That means it is a copy. Okay, it's the Xerox copy of these A and B values. So once these values are basically computed, right, the number 7 is returned here, and that number 7 is initialized into the variable C. Now, a point to be noted here. When I run this program, I have a memory allocation done for A, I have a memory allocation done for B, I have a memory allocation done for C, but because of this function, two separate memory allocations are again done, okay, because the copy of these functions are initialized into these two separate memory locations, which are declared by A and B. Okay, now in this program, all the variables that we have used, ABC here, ABC in the main, as well as ABC in this function block, they are all local variables. They are all local variables. Okay, that is the reason I am using ABC here also, AB here also, because they are local. Okay, what it means is that this ABC and this ABC, there will be no conflict. In fact, I can actually remove the A and B here because the values 3 and 4 are, you know, being sent here. I can store them in any variables that I want. It need not be A and B, because this A and B is not at all connected with the A and B here. So what I can do is I can write this program using different variables also. So what I can do is I can change this program. I need not write A and B. I can write X and Y here. There's no issue at all. And then when I do the computation here, A plus B, rather than A plus B, I can do X plus Y. Okay, so these two values, which are actually, you know, allocated, they're temporary values, they will be allocated as X comma Y. So just remember that it's not necessary to write the same variable name here that you are writing in your program. Okay, the reason why? Because you are sending a copy of that. When you're sending a copy of it, another variable can hold that copy and do the, you know, whatever operation it has to do and return the value. So once, when are these two values initialized? So once this add function takes these two variables, right, and comes to this the main block, the body, these two values are created in memory. As soon as the sum is returned from here, these two X and Y are removed from the memory. Okay, and only A and B remains. All right, inside this block, this A and B will not be available. This A and B is not available inside this block. Only a copy of these values are sent to this function body. Did you understand this? I just need a small confirmation from you. Did you understand this concept? Can you just give me a...
Yes, sir.
Yeah? Okay, fine. This way of passing arguments into a function, okay, this method of calling a function by passing arguments, okay, is called as pass by value. Okay, we are passing the actual value of A and B here. So when you pass the actual value, a copy of those values are made and then taken to the main function body. So this method of passing your arguments or passing your parameters are called as pass by value. Please remember that, it's a very important concept. So in pass of value, additional memory locations are created in your function body. Okay, a copy. So in order to make a copy, you need to have two separate memory locations where you're going to store those values, right? So we need additional memory in order to perform operations, you know, on functions, which is passing the arguments as values. Okay, let's look at another variation of this. So same program, I've written it once again very neatly here. There is no difference. All of you can understand it clearly. Now in this case, I am not going to pass the value, but I'm going to pass the address of the variables. So I'm going to pass the address of A and B into this body. Okay, this time I'm not going to pass the value, but I'm going to pass the address. So let's see how that works out. Okay, so let's see how that works out. So the first thing, this line is fine, everything is clear here, right? We are initializing the three variables. So how does that variable look like? variable looks like this. So A is here, B is here, C is here. In this line of the code, we accept the two values from the user. So let's say I accept the value 3 and 4, all good so far. Now, at this line of code is where I change things, okay, where I'm going to change few things. What I'm going to change. Now, rather than passing these values, I'm going to pass the address of these variables. That means, suppose the address is this one, right? Suppose what is the address of A will be ampersand A. What will be the address of B will be ampersand B, right? All of you know that in order to find the address, you need to use the address of operator, which is given by this symbol, right? So I am going to pass the address of A and B here, not the actual value. So what I do is I will write this. This is the address which I'm passing. Now, first important thing, when I pass address in a function, here the function body is written in a way that it is accepting two integers, right? Here, if you look at the prototype, or if you look at the definition of the function is written in a way that it is accepting two integers. But what I'm doing is I'm passing two addresses. So I need to change this line of code, and I need to write the definition in a way that this function accepts two addresses. So when it accepts addresses, that means we are talking about pointers, right? So in order to store these addresses, we will need a pointer variable. We will need two pointer variables, A and B. Okay, so we have to declare those pointer variables. So here you see I have declared two pointer variables, A and B. All right, so what is going to happen is, now this A, the A which is written here, right, star A, this star A is basically holding the address of this A, and this star B is holding the address of B. Now, just to make things a little bit clear, I'm going to change this A and B from A and B to X and Y. Okay, so I'm going to change this from A and B to X and Y. Okay, here you go. So I have declared a pointer variable which is X. Now this pointer variable X is going to store the address of this variable A. So when I'm passing the address of A here, this address is being stored into a pointer variable X. This address of B is being stored into a pointer variable Y. So I need to change this line of the code. All right, so now when I want to perform the calculation, that means when I need to find the address, when I need to find the value at that particular address, which operator will I use? I will be using the dereference operator, which is this. So when I write star X here, it will extract the value at that address. Which is that address? And A. What is the value at that? 3. So star X will give me 3. Similarly, Y is giving me the address of that memory location. If I want the value at that address, I need to specify it with star, right? So once I write star Y, it gives me the value 4. And now 3 plus 4 is equal to 7. And this 7 is going to be returned. So I will have 7 here, and this 7 is going to be initialized into the variable C. And here I print that 7 using the variable C. Now, first of all, I would like to know whether you understood what I'm trying to explain here or not. So can I just have a quick... Yes, I hope everybody's understood this because it's an important concept. So the only thing we did is that... One thing. Yes.
Sir, in a int main function,
yeah. Yes.
Input ABC, then return all things are where output.
No, I can't get you. You can tell me again. I input 3 things. Where is the output?
Yes, sir. In int fact, sir, in ABC int. Sir, ABC हम int में. Yes, sir. Int main function में, sir.
Okay. This is the line. Okay. Then what?
Sir, इससे मेरा जो यहाँ से प्रोसेसिंग स्कैन ऐप से जो प्रोसेसिंग हो रहा, उसके आगे रिटर्न जो करेगा मेरा सर रिटर्न जो करेगा रिटर्न वैल्यू.
Yeah. That return value is going to come. The value is going to be returned here. This is the place where the value is going to be returned.
Okay, sir.
This function, so return, this function is going to return at the point where the function call was made. Where was the function call made? The function call was made here, right? So the value is going to be returned here at this point. So this is going to return here. So that's why the value 7 is going to come here and it will go into this variable, C.
Okay.
Is it clear?
Okay, sir.
Is it clear? Okay. Now, one small difference here. Now, what is the difference between, so this method of passing the address as the arguments to a function is called as pass by reference.
Pass by reference.
Okay. So there are two ways by which you can pass your parameters into a function. One of the way is pass by value, right? Second is pass by reference. So I gave you the example of both, right? In the previous example that we discussed, we were doing pass by value. In this example, I changed only three things. Please take a note of it. Please make a note of it. The first thing, in place of A, I put this, I pass the address. Second thing, I change this function definition to specify that what I'm passing is not a value, but an address. So I am declaring a pointer variable here. And third, in order to access the value at that particular address, I'm using this star as a dereference operator. So this star is used in two different contexts. Here it is used as a dereference operator. Here it is used as an operator to declare a pointer variable. Okay, so this is a very important concept. Pass by value and pass by reference is a very important concept. Okay, now I want to tell you another difference between these two. If you look at the previous program, right, here A was initialized at 3, B was initialized at 4, right? A was initialized at 3 and B was initialized at 4.
Yes, sir.
When I passed those values 3 and 4 here, right, I was passing the copy of these 3 and 4. So A and B was actually carrying the copy of 3 and 4. So when X and Y, here in this function body, a copy of 3 and 4 was available. So if I did X is equal to X plus 5, what was happening? The changes were happening in these X and Y. So what was the copy of the value of X? The value of X was a copy of 3. So X contained 3. So when I did X is equal to X plus 5, this changed to 8. All right. However, this value did not change. This value did not change. Only this temporary value X became 8 here. Right. So when I came out of this loop, these were deleted. As soon as I came out of this function body, this did not remain in the memory. So your original values of 3 and 4 remained in this particular memory location. So your value of A and B did not change.
But in case,
yes,
here X is the ampersand used. What is the, and X plus also X plus 5 are used.
Here.
Sir, int function, add function में sir.
Yes, in add function what?
Sir, int ampersand X equal to X plus 5.
Int ampersand X is equal to X plus 5.
Yes, sir.
What is this? We cannot declare using ampersand. We cannot declare any variable using ampersand. You can only declare as X and you can declare as star X. Okay, but what you can do is if you have an address, then you can store an address straight away here, but I can't declare like this.
Okay, sir.
Okay, fine. So let's look at the second example. In second example, what is happening is I am not actually taking the copy, but these values are being computed from this memory location itself. So in this block of code, if I do star X is equal to say star X plus 3, okay, then what is going to happen? Star x is equal to star x plus 3. Then what is going to happen is the memory location which is pointed by x is this one. I am incrementing by value 3, right? So this a value will change here to 6. Okay, because here I am not using temporary variables, but I am using this when I'm doing the calculation. I'm working straight on this memory location, because what I am doing is I am passing the address here. So using this address, the calculation is being done by accessing this memory location, not the temporary value. So when you're working with pass by reference, and if you make changes in the variable, if you change the value of the variable, those are reflected in these values here in the main program also. But in case of pass by value, if you make changes in the variable here, those changes are going to only reflect in your temporary variables which you're going to initialize. And as soon as you come out of this function body, these temporary variables are they disappear from the memory. Okay, so when we are using pass by reference, you need to be careful, because any changes in the value will directly change your master data. Okay, so it's something like this. In the pass by value, suppose here is a memory location A, and you want some calculations to be done. So by pass by value, what you'll be do, this 5 is not given, but a copy, a Xerox of 5 is given. So any manipulation, any changes, anything that you do, you are doing it on this copy. Okay, so this original value will not change. But if you are using pass by reference, then you are giving the address. That means you are working directly on this value. So if you make any changes, the original value will be lost. It's a simple case. I will tell you, when you take a photograph, okay, suppose you take a photograph and it is there in your hard drive. Now you want to do some editing on the photograph. There are two ways by which you can do the editing on your photograph. One way is directly take that image, open it in your Photoshop and start doing editing there, and you save it. So when you save it, your original image no longer exists, because you are saving directly, or you're making the changes, or you're editing the photograph right on your original image. That is basically pass by reference. But suppose you want to make sure that, okay, I want to keep a copy of it. I want to make all the changes in a copy. So I keep my original, make a copy of that image, and on that image, I will make all the changes. So whatever changes I make on that image will not change my original image. Now this example is the pass by value. So when I do pass by value, I make a copy of it, and all the calculations and everything, all the processing is being done on that copy. When I do pass by reference, all the computations are being done on the original memory location. That means on the original image. So I hope now it's clear, because I've explained it to you in pretty detail.
Yes, ma'am. Yes, sir.
Yeah. Okay. So this is a very important concept which is going to come across, everywhere. Okay. In all programming languages, you'll have this concept of pass by value, pass by reference, and any interviews you go, this is a must question. They will ask you this question. All right, so let's move on to another program and see how we can. Now, when you have a function, when you're passing values to it, when you're passing integers, floats, characters, you can pass anything. You can also pass an array. Okay, you can also pass an array. So if I have this same program where, I want to basically find, say, for example, here I have written this program to find the sum of two numbers. Right. So suppose what I want to do is I want to write a program to add 3 numbers or 4 numbers or 5 numbers. Now it becomes tedious, right? I can't enter 5, 6, 7, 8, 9, 10 times A, B, C, D, E, F, G, H. I cannot have 10 parameters, 7 parameters, 8 parameters. This becomes complex. So what I can do is I can declare an array. I can have the 10 elements in an array, and I can just pass that array in this function. And once this array is passed into the function, in the body, you can always accept that array, then open that array, look into all the elements and make the, you do all the operations on, involving all the different elements, and then you give the result back to the function. So I have already written this code just to save some time. So if you look at this program, first look at this side of the program. Okay, look at this side of the program. what have I done here? The first line, I have declared an array. What is this array? It's an integer array. What does it contain? It contains, basically, I've declared an integer array of only 3 elements. Okay, so I can store 3 numbers there. I have initialized I to run a for loop, and this C is basically the same C which is going to store the result. Okay, so first what I do is I initialize this for loop. Like basically I run this for loop, and inside this for loop I basically accept 3 times 3 values. So the first value goes into 3-1, second value, sorry, 3-0, second value goes into 3-1, third value goes into 3-2. Everybody's clear with what I have done here? Yes, just give me a thumbs up or yes or something.
Yes,
Yeah, okay.
Yes,
So
yes,
what I've done here, everybody's clear. I've used the amp. It's same, nothing, you know, there is nothing complex here. What we have discussed in array, this is plain Jane simple. Okay. Now what I'm doing here is something different. Here I'm passing this array. Okay, look at this. What's the name of my array? Is 3. So I'm straight away passing this array here. So simple. I don't have to pass A, B, C, 3 numbers, 4 numbers, 5 numbers. Now, if my array is 100 numbers, 100 element. If my array contains 100 elements, no problem. I just pass my array here. Now, after I pass this, so this function, basically, this function add is a function which accepts an array. So when I define this function, I have to write, and I have to basically, kind of point it out to the function that, look, my function is going to accept an array. So this is basically a declaration which tells that this function is going to accept this array, right? Now, I can use a different name also. I told you here, this is passed by value. So I can change this name here, and I can, rather than writing 3, I can write, my own name here and use the same name in this function body. But here I have continued with 3. So now what I'm doing here, I have taken a temporary variable because I am going to calculate one element. I'm going to extract one element, and add that into the sum, then take the next element, add into the sum, take the next element, add into the sum. So I have declared a temporary variable sum with value 0. And each element I will keep adding to this sum variable. So at the end of it, I will get the total sum of 3 numbers. Then I have declared I here. Now the reason why I can use I here for the for loop, I here for the for loop, is because they are all temporary variables. Okay, they will not, kind of conflict with each other. They are available in a local scope. I talked to you about memory. I talked to you about storage classes. I talked to you about stacks and static. So they are all available in the local scope. That's the reason I can use I in, in the main, in the function, everywhere. But if I declare I as global, then there will be an issue. Okay, fine. So this line is clear. What I've done is I'm running this loop. How many number of times? 3 times. So first time, the 3-0 will take the first number, 3-1 will take the second number, and it will put it into the sum. And finally, all the 3 values will get added into the sum, and I'm going to return the sum, this sum, whatever value is there. So if you enter 555, it will return 15. This 15 will come here. This 15 will be returned here, right? And then this C will have the value 15, and you can print the value of C here. So this is a very simple program by which I am passing an array into a function. So if I can pass a value, I can also pass an array. Is that clear, everyone?
Yes, sir.
Yes, sir.
Okay, fine. Now, please remember that you need to practice these programs. Okay, whatever I'm giving it to you right now, you please execute the same program and then try to sit back and try and visualize that what is happening and why it is happening. If you can connect why it is happening, and if you can connect, okay, how it is happening, then your concept will be clear. I'm once again telling you that please do not try to rush and learn and remember these programs. You have to understand them conceptually. Okay, you have enough time, you have enough time to do lots of programming, but right now is the time to get the basics. So you need to understand all the fundamentals clearly. If your fundamentals are clear, you can go to high-level programming much more easily, but your fundamentals need to be strong. All right, now before we move on to the next bit, I want to once again touch pointers. Okay, let me just get to pointers once again. All right, so all of us know what's a pointers, right? All of us know what are pointers. Now we also know there's a relationship with pointers and array. Now this I have discussed earlier, but we will see exactly how this helps in kind of array operations. Okay, now what is a pointer? A pointer is a variable which will point to a memory location, and depending on how we declare the pointer, we are also, the pointer also knows what kind of memory location it is accessing. That means what is going to be present inside that memory location, what kind of data is going to be there in that memory location. So if I declare a pointer of integer, right, p, so the p will be actually pointing to the memory location where an integer value is going to be there. Right, so integer value, say it has memory location, how much of memory it occupies. Say my compiler is giving 2 bytes to integer. Right, if I declare a floating point pointer, right, so this p is now going to store 5.6f, like this is a floating point number, and say my compiler allocates 4 bytes to this. Okay, so the pointer also knows what kind of data exists in that memory location. Now this concept is very important. Why am I coming to that? Now let's come to the main part. Now if I have variables like a, b, c, and all of them declared as integers, right, so they will be stored in different parts of the memory. Okay, a will be stored in different parts of the memory. But if my memory is divided into, say, suppose my memory size is, say, 1 byte, okay, 1 byte per block, then this integer will basically store 2 blocks, right? So these 2 blocks will be stored by an integer. So suppose I have a floating point, so sorry, not an integer, but suppose I have a floating point number, and this floating point f is allocated into memory. So we know, suppose floating point uses 4 bytes and my memory block is divided into 1 byte. So how many bytes are reserved for that one floating point? 4 bytes. Okay, so one floating point will occupy 4 bytes. Okay, now let's come to the fun part of it. Now suppose I have a pointer variable. Okay, suppose I have a pointer variable, say star ptr. Okay, so this is my pointer variable, and I have declared it as an integer pointer variable, right? So let's write a small code. Let's say int a is equal to 10, and I am declaring a pointer variable star p. Okay, and this p I am going to point to the variable a. Okay, so how will it look into memory? So this is basically how the memory looks like. So each memory block is divided into 1 byte, right? My a will be allocated into 2 bytes. So this is basically the storage that is allocated for a, right? Now this p is pointing to the address of a, right? So p will be pointing to the address here. So it's 1010 in binary. Say this is my address. P will be pointing to this. Okay, so p is pointing to this address. Now the fun part is, if I do p plus 1, this is also called as pointer arithmetic, and it's very, very important. Okay, so I can basically do pointer arithmetic. So what should actually happen when I do p plus 1? Normally what should, normally people will think that, oh, whatever is the memory address which is being held by p, right, one block will be added to that memory address. So my p should come to the second block here. If I add p plus 2, it should come to the block here. If I add p plus 3, it should come here. Okay, so the p should point here, or it would come to here, it would come here, or it would come here. But that's not what actually happens. Okay, if there is a very important property here, that if your pointer is pointing or has been declared as an integer, then this shift will be the size of that integer. That means if we are talking about p as an integer, and if the p is pointing here, that means if I do p plus 1, what is going to happen is this pointer is going to be shifted by how many places? 2 bytes, not 1 byte, because this is an integer pointer and integers hold 2 bytes of memory. So this P will, suppose if it was pointing here, then it next, if I do P plus 1, it will point to this location here. That means it can point to the second place where maybe another integer value is stored. Okay, suppose I declare a pointer as a floating point pointer, PTR. And now if I do PTR plus 1, by how much this PTR is going to shift? In this case, it is going to shift by 4 bytes. Why is it going to shift by 4 bytes? Because a float is normally a floating point variable, a floating point number basically occupies 4 bytes of memory. So the pointer shift will happen by 4 bytes. So did you understand this concept? So the whole point here is that if I do pointer arithmetic, so if I declare as pointer arithmetic, and if I declare this pointer as integer, so PTR plus 1 is going to shift by 2 bytes. The address that PTR will have will be the address of a new memory location, which is offset by 2 bytes. If I declare a floating point pointer, and if I do PTR plus 1, then this PTR is going to shift by 4 bytes. So if this is my memory location, right, and this is 1 byte, 2 byte, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose there are 10 bytes in this memory, and this PTR is pointing here. So in case of integer, if I do PTR plus 1, it will jump here. Okay, but in case of floating point, if this is a floating point number and PTR is pointing here, if I do PTR plus 1, then it will jump by, it will come here. That means 1, 2, 3, 4 bytes it will jump. Did you understand this? Did you understand this?
Yes, sir.
Okay. Now, why am I bringing this concept of pointers and this important property of pointers is, now let's talk about an array. How is the array, allocated memory? So if I have an array, so array is allocated in this way, right? Suppose this is an integer array, right? So suppose this is an integer array and it has some numbers. Okay, now we know the very important property. So in order to access this array, I have to write ARR0, ARR1, ARR2. So this is how we access, these arrays, right? These elements of an array. Now, if I have a pointer variable, let's take a pointer variable, right? Which is an integer pointer. Let this be an integer array. Okay, I take an integer pointer. So I declare an integer pointer, and now you know that PTR is equal to ARR. I can do. Everybody is clear with this? Because array and pointers have a very close relationship. Array, the name of an array is basically the address of the first memory location of that array. So ARR is actually pointing here. Okay, that is the first memory location. So I can do PTR is equal to ARR. That means PTR will also point here now. Are you able to understand?
Yes,
All
sir.
of you, are you able to understand till where I have taught you right now?
Yes,
Okay, now let's continue. So once I do this, if I do star PTR, what will be the value of this? Can anyone tell me? What will be the value of this? In this example, what will be the value? Value will be 3. That's perfect. Okay, so now if I do PTR plus 1 and then do star, what will be the value?
It will be 7.
The value will be 2. Okay, the value will be 2. That means by using this point, yeah, it will be 2 because this is integer, so this carries 2 bytes, 2 bytes. Okay, so everything carries 2 bytes, right? So this is 2 bytes. So because my array, my pointer is an integer array, integer pointer, so it will shift by 2 bytes. All right. So if I do PTR, it will point to the first element. Okay. So if I do PTR plus 1, it will point to the second element. So if I do PTR plus 7, it will point to the sixth element. Are you all able to understand?
Yes, sir.
Okay, so I can
Yes, sir.
access the elements of an array by a pointer variable very easily. So all I need to do is find the location, jump to the location using PTR1, PTR2, PTR. So the value of PTR, so whatever address is there, so I can do PTR plus 8, and this is basically going to point to the 7th location, and at that address, I just extract the value by using the dereference operator. So using pointers, I can easily manipulate the values of an array. So I can do star PTR plus 5 is equal to 8. What is going to happen here? Right? It is going to point to PTR plus 5 means it is going to point to the sixth element. Right?
Element.
Sixth element, isn't it? PTR is pointing to first, so PTR plus 1 is going to point to the second, so PTR plus 5 is going to point to the sixth element. So the value of sixth element can be changed directly to 8. Okay, so this way I can manipulate or I can change the values of an array, and I can very easily perform operations on an array using a pointer variable. So this pointer arithmetic, I can even do minus. Okay, so if I do PTR minus 5, then it is going to go this side and go to the memory location which is on the left of it. Okay, so I can perform a lot of array operations by using a pointer. The only reason, because pointers and arrays share a very close relationship. Now, what I have taught you today is a very, very important concept. I hope you've understood. Now, I wanted to actually write another program and show you. I don't know whether will be able to take it or not, but let's leave it now. Now, what I want you to do is, let me just explain a little bit about that program. Let's go to that program where we had done the array. Now, in this program, if I want to pass the pointer variable, what I can do is I can point. Let me write it in a clean board. Okay. Now what I can do is I'm just writing it rough. Okay, I'm not writing the entire program. Just try and understand what I'm trying to do here. So I can easily declare a variable. I can easily declare a pointer. So let's say this is my array, right? Now what I can do is I can take another pointer variable, right? I can easily take a pointer variable. What I can do is I can take this pointer variable and point to this array. This is clear, right? This is absolutely clear. Now what I can do is I can use a loop, let's say for loop. Okay, and the for loop I can int I for the loop. For I is equal to 0, I is less than 3, and I plus plus, because there are 3 elements. Now look at this line. Okay, I am scanning and I'm taking this input from the user. Now this line what I'm writing is important. Now what I'm going to do is, if I do star PTR, what does it mean? It means that because I have done PTR is equal to 3, that means this is my array, 3 elements in an array. My PTR is pointing to this particular element, right? This particular, the first element of an array, the PTR is pointing here. So if I do star PTR, it means the value at that, right? So if I just write this line of code, the value that the user enters will get placed into this particular memory location. Absolutely, everybody is fine with this?
Yes, sir.
Yes. Okay.
Yes, sir.
But because I'm running it in a loop, so I need, in order to access this, I need PTR star. In order to access the second element, I need PTR plus 1 star. And in order to access the third element, I need PTR plus 2 star. Absolutely fine. So what I'll do is, rather than doing this, I can write PTR plus I, right? And here you go, because this is the for loop is running. So the I value will change. First time it's going to be 0. So you're going to get this. So my first element I can enter. Then second, it's I value is going to be 1. So I'm going to have PTR plus 1. So I can enter my second value, and then PTR plus 2, which is the third element. So all my 3 values will be initialized here. So using a pointer variable, I am initializing the values of an array in this case. Everybody is okay with this much so far?
Yes, sir.
Okay.
Yes,
Now
sir.
let's move on to, let's pass this array. So how do I pass this array? So basically, let's say I have C here, the same program, same line here. I've written add. Now, earlier I passed an array here. Earlier I passed some addresses. Earlier I passed some values. Now I'm going to pass this PTR. So what I've done is I have passed a pointer variable. What this pointer variable has, this pointer variable is basically pointing to that array. Okay. Now, when I pass a pointer variable into this function, so I need to change the definition of the function, right? So I need to write int. Now, in this case, I am passing a pointer, so I can write PTR. This is my function body now. Are you able to understand this? Because I'm passing an address here, right? PTR is holding the address. Address of what? Address of this array. So this star PTR means that the value which is being passed is not a normal variable, but it's a pointer variable. So I need to declare this using a pointer, right? Now here what I can do is I can take int sum is equal to 0, right? I can take int I to run the loop. I can do a very simple thing. I can run a loop. I'm not writing that. The loop, now what I can do is I can do sum is equal to sum plus PTR plus I, and I'm going to access the value using this star operator. So PTR first value is going to be 0, I value is going to be 0. So star PTR will give me the first value here. Second I value is going to be 1. So PTR plus 1 means it is going to point at this memory location, and star that memory location is going to give me this value. Similarly, PTR plus 2 is going, PTR is going to jump to this memory location, and the star of that memory location is going to give me the third value. And all that will be incremented into the sum, and I can return sum from here, and that C, the value will come to C here, and you can print C here, and you'll get the answer. So this is another example by which I am passing a pointer. Now what am I passing? I'm passing a pointer to an array. Okay, so I have declared an array and I replace that array with a pointer. So I pointed a pointer variable to that array, and now using that pointer variable, I am accessing and performing all the operations to that particular array. So I hope this is clear, and I hope you have understood. I would request you to go through this video many number of times till you are absolutely clear about each and every concept that I have discussed. Okay? So all good?
Yes, sir.
All right. So you can now start giving your attendance, and then you can exit. Now, I want to tell you one more thing, is that once we finish, all the concepts, I will be giving you a lot of programs to do. Okay, so I am right now I'm trying to finish the major concepts of your course. Once I do that, I will give you some programs that you have to practice. I'll give you the solution for this, but each and every concept which I've discussed, you need to write some programs. For example, in the next class, let's try and discuss how we can pass a, we have talked about a single dimension array right now. Right now, what we are doing is we are passing only a single dimension array. We can pass even a 2-dimension array. So we will see exactly how you can perform, operations on a 2-dimensional array. And you can use all these concepts which I have discussed in a second dimension, right, array. So Also, we will look into what is the utility of this. So for example, if you have a two-dimensional array, you can perform matrix multiplication, matrix operations. So we will do some programs at the end of this course, like probably once I finish my arrays and all that, and then I will give you those programs for you to practice, and then you can come back to me with queries and any questions.